Now we were studying about microprocessor 8085, and now we are going to talk about microcontroller. Okay, so there is a small difference between microprocessor and microcontroller, and I believe most of you know that difference. The difference is that each and every microcontroller has got a microprocessor inside it. Okay, so each microcontroller has got a microprocessor inside it. We can call it CPU. And what else is there in microcontroller? Microcontroller are basically designed to do a specific task. Okay, these are good to do small tasks. If you have a particular specific small task for a machine or some other instrument or device, you should go for microcontrollers rather than going for microprocessors. Simply speaking, if we have to characterize these two devices, that is microcontroller and microprocessor, then definitely microprocessor is used for processing purpose. Processing is more important. When processing is more important, then we should go for microprocessors. And when controlling is more important, okay, then we should go for microcontroller. In both the case, you will be using some logics. Okay, definitely you will be using some logics, and definitely you will be using some arithmetic instructions and all. So ALU in short we can say. Okay, both will be using ALUs. Okay, but what is the difference between processing and controlling? Processing means you need lots and lots of mathematical stuffs to be completed. Okay, more complex mathematics or algorithms. Okay, when complex mathematics is to be solved, then you should go for processing. And whereas in controlling, you are just giving some instructions like switching on and off kind of stuff. So mostly these will be related to switching something on or off based on some logic. Okay, but here it is not just about just switching on or off some devices. Here it is about processing the data that you get. So what are the common applications of microprocessors? Definitely microprocessors are used in computers. Okay, computers uses microprocessor. Then along with that, in these computers we are doing video processing. Video processing is specially used for completed, especially we use microprocessors to do this particular task. Then of course, when there is a video processing kind of task, then you also have audio processing. Okay, then you can recall all the names which is related to processing. Image processing, image processing. Okay, so all these tasks require more processing kind of stuff rather than just switching on or off some device. Here you need more complex mathematics, like sometimes you need to do integration, differentiation, and then partial differentiation, and so on. Okay, whereas in microcontrollers, you are generally designing devices like toys. Okay, you are designing toys, and then you are designing home appliances. Okay, then you are using even security systems and so on. Okay, so these devices are, for example, toy. A toy is specifically designed to perform a particular task. It is not designed to process some data and then give some output at the end. Similarly, home appliances like your washing machine or your television or your VCR or VCP. Oh, these are all old things. Now, for example, CD players and all. So in that case, they are specifically designed to do some small task. Okay, and then security systems like now we are having CCTV cameras, otherwise motion sensors, temperature sensor kind of sensors which are used for designing security systems. For them we can use microcontrollers. So this is very important before switching to either microprocessor or microcontroller. Both can do processing based on their ALUs available. Okay, and ALU means, definitely it means the instructions also, instruction set, instruction set that is available with these particular devices. So these devices, microcontroller and microprocessor, before you choose these two, you have to define your task, and based on your task you should choose the device. It is not that you always go and buy the best possible processor, because you will be wasting either the resources present in the device, or you will be wasting the money if you are not properly purchasing a device. Okay, so in microcontroller we are going to start with 8051. Okay, this was the the so-called most famous microcontrollers in the beginning, and we started with 8085. Okay, but of course you can go for more complex systems like 486, and then you have Intel Pentium series, and then of course you have Intel's new i7, i4, i7, i5, i3, these kind of series. At the same time you can go for AMD processors. Okay, these are all processors developed by this. So now, but at the same time microcontroller also evolved with respect to time. So 8051 then came at mega, at mega 89 C52. Okay, and so on. Based on the same architecture 8051, they had C51, C52, then S51, S52. So Atmega is one of the most famous microcontroller designing or microcontroller manufacturing company. At the same time ARM also started developing, providing the architectures for different kind of microcontrollers, which are actually bought by so many different companies. Remember one thing, ARM never makes a microcontroller or a processor. ARM, this company is not a manufacturer. It is just a so-called kind of design provider to different companies like Apple. They purchase microprocessors or microcontrollers from this ARM company, or their design is from them. Then comes Samsung. Samsung is one of the most so-called complex microcontroller or microprocessor developers. Okay, again they use ARM architecture. Then you name it, NXP. Okay, these are all very big giant companies which are developing, or you can go for Ericsson, Motorola. Okay, Ericsson, I don't remember the spelling. IRCSS1. Ericsson, I think. Okay, so Motorola and you name it, Nokia, all of them are purchasing microcontrollers designed from ARM, and ARM is providing the design to all these companies. Okay, so now in this present scenario, or at present time, ARM is the world's largest microcontroller designing company. Okay, so anyway, we are going to start with the microcontrollers. So we have to understand the basics of this particular device, and then we have to learn how to program it, keeping all this thing in mind that we have to finish it as soon as possible so that we can start with the rest of our course. Okay, CIF, because we have one unit left in the CIF. Anyway, so this is all about the difference between microcontroller and microprocessors. Now after that, what are the other so-called technical differences between these two devices, be it microcontroller or microprocessor? So in terms of technical differences, microprocessors, okay, remember we have completed 8085. In that there was no specific memories available, be it for RAM or ROM. We only had some temporary registers. Okay, in the microprocessor. Other than that, if we have to write a program, we need external memory, be it RAM or ROM or any other external memory. Secondly, they don't have any IO ports. Okay, so there was no so-called directly available IO port. We have to use some latches. We have to use circuits to which can interface with the external world. These pins like address pins and data pins, they were not able to drive anything at the end. So called, if I have a microprocessor, okay, if I have a microprocessor, of course there will be some data bus and address bus. Okay, address bus, and we will have some data bus also. Okay, but these data bus or the voltage or current in these data bus are not sufficient enough to drive anything, even an LED or something. So what we need some interfacing circuit. Okay, like we can use latches or some other devices. So this data bus can be connected to these interfacing devices, and then these interfacing devices can interface with external world. Okay, external world. So this was one of the biggest drawback. Though microprocessor can do all the processing, he is not able to drive anything in the external world. And similarly, it does not have any peripherals, inbuilt peripherals. Inbuilt peripherals. Not available. When we say inbuilt peripheral, for example, in microcontroller nowadays there are so many different peripherals which are available, which can be used to simplify the life of the processor. Okay, for example, timer. So in the past we developed some program where we developed some counters and delays. In that, what we did, we developed a program of generating some delay using polling method. In that, microprocessor was loaded with some number. Okay, loaded with some number, and then we decremented it, and then we checked some condition. Okay, and then again we kept on decrementing the so-called, not here, we can go somewhere here, decrement the number, and we kept on doing this thing. So this is polling. This is nothing but wastage of microprocessors resources and the time both. Whereas if suppose we had a timer inside the microprocessor, then what the microprocessor can do? Microprocessor can load the time or the number into a timer. Okay, and the timer will do the task of delay. Okay, sorry, delay. Wait a second. Okay, timer can manage these delays, and once the delay is over or the final or terminal count is reached, the timer can generate an interrupt to tell the microprocessor that okay, I have completed your task, and now this is the what you need to do after that. By that time, this time during the delay, microprocessor can do some other task. So in that case, microprocessor will be using his resources in a more intelligent fashion. So timers are not available in your microprocessor. Similarly, ADC, analog to digital converters. Analog to digital converters, for example, if we have a microprocessor or a microcontroller, or I can say processing device, okay? And in that processing device, definitely these processing need two things. One is the input, and he will process the data, and we need to generate some output. Okay, so there is no benefit of using a system without any input. So input can be provided by input devices like keypad or switches, or sometimes sensors. Sensors are very important to provide the real time data from the external world. These sensors generally or mostly 99.99 all these sensors provide the data in analog form. Okay, analog form, this can be three different types of sensors, like they can generate voltage in analog form, they can generate current in analog form, and I don't think there will be very rare sensors which will provide some power related to the input world. Okay, so power, voltage or current can be provided to processor. Now the question is, these are all analog values. Analog values, you remember, they fluctuate continuously, so there is no so-called predefined sequence here. Now we need to have something in between the processor and the sensors, because processor is purely digital. It will work on binary bits like zeros and ones only, whereas analog can have so many different transitions. Now there can be a device which can be plugged into this so-called processor, we can call it ADC, to develop or to generate equivalent digital value for the analog signals which are produced by the sensor. So this kind of peripherals are very handy when it comes to interface with the real world. So definitely microcontroller has its own microprocessor. It has got RAM and ROM. That means it has got the memory inside the device itself. It has got input output ports. That means it can interface with the external world. It can drive many of the simple devices directly. Then it has got timer circuits inside it, so that it can generate different delays or interrupts based on those delays, okay, or count some numbers. Similarly, they can have ADC, DAC and other peripherals. Now the challenge is to develop more and more peripherals, or include more or more peripherals into the microcontrollers. So this is the advantage of microcontroller. So microcontroller has got its own CPU, its own RAM, ROM, IO port, timer, serial communication, or not only serial communication, it can do many other communication also, like SPI, I2C, okay, or CAN bus and all. So definitely microcontroller is evolving with respect to time, and it is including or embedding more and more complex peripherals into the chip itself. Okay, so definitely you must have to use data bus and address bus. These data and address bus are connected with all the peripherals, be it RAM, ROM, IO ports, timers, communication based devices. Okay, the CPU, of course, the CPU now again is an important part, but rest we have to keep an eye on all the peripherals. What are their address? What are the features available in those peripherals? How can we access those peripherals? What are the limitations of those peripherals? So until unless you know all these things, you cannot write a genuine code for the microcontroller. So you have to keep everything in mind now, that what are the behavior of IO port, what are the address of IO port, what are the timers specification, how can we handle those timers, okay, and then of course communicate with the external world using serial or parallel communications. Okay, so this is all about microcontrollers basic detail. Okay, now where are these devices generally used? The embedded systems, or you can say the microcontroller based systems, they are mostly used in home appliances like security system, television, remote control. You look at your home, almost all the devices now which are being developed are developed using the microcontrollers. There will be some kind of processing device inside almost every electronic gadget you see, and those processing devices can be very complex or very simple depending on the task that device has to perform. Similarly, in automobile, nowadays in automobile, you can see huge revolution coming in the automobile sector, and this is all due to the use of embedded systems, ICs and processors. Now in the past we used to have specifically engines in the cars, motorbikes, trucks, or any other device, any other automobile. But now, slowly and slowly, all these things are being changed by the electric engines. So definitely now these engines, be it electric or be it petrol based or oil based engines, they all have this kind of devices embedded in them, like engine speed sensor. What is the speed by which the engine's pistons are rotating, or whether the engine is rotating itself. Vehicles speed, what is the speed of your car or bike or anything. Now almost everything is digital. Same brake, how the brakes, now if you check ABS and all, they are very intelligent braking systems. They are not just mechanical brakes, they are very complex programming based brakes. Okay, so then we have accelerometers, how fast you are accelerating, driver belt sensor and all, you name it. Now if you see, you will find more and more electronic components are being embedded into an automobile rather than mechanical components. So with respect to time, automobile sector is shifting slowly and slowly, gradually, from mechanical to more towards electrical. Of course, still there will be mechanical parts important, like how much torque it can generate, how much wear and tear it can handle, what kind of aerodynamics are there. Of course, they will be there in that automobile, but the core of the automobile is changing. Now the automobile are becoming more and more intelligent. Okay, so self-driving car and all. So more and more embedded systems are included in them. Then of course, one of the biggest and the largest consumer of electronics. So the biggest consumer of electronics is not home appliances or normal people. It is defense, which pays the highest amount of money for these embedded systems. In defense, you can see guided missiles. They are very important. Of course, these are the most expensive devices that you can develop or sell to any person. Quadcopters. Now you can see most of these uh, defense based systems are either using quadcopters or aerial vehicles which do not have a human being inside them. Okay, so definitely there is a shift from human being to machines, and these machines are more intelligent, most of the time more intelligent than the common people, and they are using all these embedded systems. Infrared cameras, GPS, radar systems, you name it, there are so many different types of devices or equipments which are procured by the defense systems, and defense is the highest so-called consumer or the biggest consumer of embedded systems in this world right now. Then of course, in your office you can see telephones, fax machine, printers, copiers, pager. So just imagine how, wherever you see in today's era, be it mobile, be it your toy, to defense or to satellite or to you name it, if there is electricity flowing in that device, mostly you will find that there must be some embedded system working behind that device. Okay, so almost every device now is controlled by embedded systems. Of course, now with the advent of upcoming technologies like IoT, machine learning and all, okay, robotics, you will see more and more penetration of these embedded systems in our daily life. Okay, so there is a huge demand for those who can work in these things. Okay, embedded system, remember, is not only about programming, it is about hardware, how to understand those hardware and keeping the knowledge of hardware in your mind and writing codes for them. So definitely it is not about just writing a code, it is basically writing a code for some hardware, specifically for some hardware. You have to have a good knowledge about the hardware to write a good code. Otherwise, just understanding C or just understanding Java or any other language, you can just go to some statistics based companies where you can predict what can be the share markets value and all those stuffs. But anyway, other than that, everywhere, be it medical, of course there is a huge demand in medical industry also. And again, the most expensive devices that are generated, most expensive when I say, are either in defense or in medical, not for consumer electronics. Medical devices are more expensive than any other consumer electronics, okay? Because they have to meet some stringent requirements. They are very tight to design them, okay? They have very, very specific requirements, and if until unless you meet them, you cannot sell these electric medical devices to the market, okay? Okay, so now you can understand why embedded system is so important, and how can one move into this sector and develop his career around that. So you need to have a good knowledge about the hardware, at the same time a sound knowledge about the software also. So now it is very clear that it is not that electronics engineers cannot do programming. We have so many different programming languages, of course, for electronics, especially for electronics itself, okay? Other than C, C++, Java, you name it, almost all these languages are basically used for hardwares only, okay? Now, what are the important parameters that a user should keep in mind before buying a microcontroller? So before buying a microcontroller, the user should check what is the speed of the microcontroller. So to check the speed of the microcontroller, what should be the parameter that a user should look at? So suppose if you want to buy a microcontroller, how you can check whether the microcontroller is fast enough or not? By which specification you can know whether the microcontroller is fast or not? कौन सा स्पेसिफिकेशन होगा जिससे पता चले कि माइक्रोकंट्रोलर फास्ट है या नहीं है?
Clock speed.
The clock speed, yeah, the speed of the clock, okay? So the speed of the clock, of course. And now multi-core, if there are multiple cores in the microcontroller, then of course the multi-core means simultaneously 2 or 3 cores can be utilized to do the same task, and result will be much faster than normal single core microcontrollers. So the clock is the most important thing, first important thing, the speed, how fast you can drive the microcontroller. Second is the packaging. Packaging means how the microcontroller or microprocessor looks like, whether it is based on this so-called, if you remember, you might have used this simple ICs where you have this kind of legs, okay? So we had this kind of ICs in our lab where we had legs, and we have to, in the PCB you have to make holes and then solder these kind of devices. So these are DIP devices, okay? Whereas at the same time there are more and more complex packages. Packages means the package in which the device is coming, like SOT, flat packages, ball grid arrays and all. So if you want to see the packages, just a second. Let me show you the packages. Different IC packages. See, okay. So these are all packages. DIP, ZIP, okay. These are all packages. Other than that, now when we talk about microcontrollers or microprocessor, we are more focused on these kind of packages, okay? Like this. Wait a second, let me check if I can show you that. Like this. Which kind of package are you using? So all these are microcontroller kind of devices where you can have the same microcontroller in DIP, PGA, TSOP, QFP, okay, flat packages. This is flat package. PLCC, BGA, this is ball grid array, So there will be small balls in this so-called, these are solder pins which are small and very these are almost like the balls, okay, small balls, and you just place it on the specific location and just heat it, it will solder up. Okay, so these are the different packages which are available. Like this one, at the center now, microprocessors are mostly designed in this kind of packages, PGA. Okay, how can you know whether which kind of package you have with your system? For example, if you write at mega 328, okay, so this is one of the microcontrollers, and I told you when you start with the microcontroller you should always go with the data sheet first of all. So in the data sheet you can see here peripheral, and it talks about the package. Wait a second, let me check where is the package definition. Okay, you see here, so TQFP, this is one of the package in which the device is sold. Second is MLF, this is another package in which the microcontroller is sold. Other than that, DIP and all, those are all the features, different types of my packages in which the particular device is sold. So generally you can find this kind of packages detail in the data sheet itself. Okay, I believe if I go down there must be, okay, this is a, okay, this kind of device packages are there. Okay, so packaging information is very important when you are designing your system, because until unless you know the packaging details, you cannot design the whole PCB around it. Okay, so it is very important to know the packages. Now after that, power consumption, this is one very important feature, because nowadays when we are developing systems, we are mostly developing the systems for battery oriented devices, like whether you are using remote control or some other mobile device and all, you are mostly using battery to supply the power. So the lesser the power, okay, remember microcontroller is one of the most power hungry device in your embedded system. It is the most, we can say it is the most power hungry device. Other than that, of course, there will be power amplifiers which will be consuming a huge amount of power. So these are the two devices which generally consumes the most power in your whole embedded system. So if you can reduce the amount of power which is consumed by the microcontroller or power amplifiers, you can save a lot of money in the batteries itself. Okay, you don't have to recharge the battery again and again. So nowadays these microcontrollers are developed which can consume some nano amperes also, of course not in working mode but in sleep mode. So there are microcontrollers which just consume nano ampere current, keeping in mind, okay, 3.3 volt or 5 volt, okay, supply. So nano ampere current and 5 volt, it will be some watt itself. So in power terms, now we are almost developing devices which can consume nanowatts. So that means even if you have a small pencil cell, you can drive that IC for at least for 3 years, 4 years. That means by that time the battery dies automatically by its own power consumption. So the battery dies its own due to its own so-called degradation rather than the power consumed by the peripheral itself. So just imagine, until unless you choose proper power consumption based devices, you cannot achieve those kind of devices. Okay, so for example, wrist watches. Okay, even now we are focusing on mobile communication, mobile devices also. So these devices are consuming almost no current when they are in sleep mode. When you wake up, make them wake up, they may consume some milliampere current, but still, so this range between nanoampere to milliampere. So you can design devices which can consume almost zero current from or zero power from the battery. Okay, so these are very important power consumption. For example, now we just had this particular data sheet. If you check here, okay, operating voltage range, here you can see 2.7 volt to 5.5 volt. So you can drive this particular IC between these two voltages. And you see here the low power consumption specifications: 1.5 milliampere at 3 volt, keeping the clock at 4 megahertz. So if you don't have to complete a task in a very small time period, or if you can have a smaller speed or slow speed clock, for example 4 megahertz. 4 megahertz is not a small speed, it is very fast. Okay, it is not slow in. So here this 4 megahertz is enough to do almost your daily routine tasks. Okay, so just imagine at that time it consumes only 1.5 milliampere current at 3 volt. So multiply these two, you will get the power in terms of watt. So some milliwatt itself. Okay, so it is having just milliwatt of consumption when it is in active mode. When it comes in power down mode, that means in sleep mode or something, it just consumes 1 microampere at 3 volt. So that means 3 microwatt almost when it is in sleep mode. Okay, so many a times we don't need system to be always awake. For example, if you are designing a sensor, okay, sensor node, you don't need the node to send the data in every nanosecond or in every picosecond or in every millisecond. Sometimes it may be important to send the data only in an hour or in every 5 minutes. And in that 5 minutes, the device can wake up for some milliseconds. Suppose assume 1 millisecond. After every 5 minutes, okay, after every 5 minutes, the device wakes for only 1 milliseconds and transmit the data, and then again sleep. So in every 5 minutes, it is working only for 1 millisecond. So that means you are consuming almost zero power for this sensor node, and you can extend the life of battery in such a long duration where the battery dies itself. It is not due to the sensor node's power consumption, it dies because of the internal resistance of the battery itself. Okay, so now there are so many things that the embedded designer can plan around. Okay, now third is the amount of RAM or ROM in the chip. RAM to handle the variables. Okay, remember RAM is used to handle the variables mostly, and then ROM is used to handle the program of the user. Okay, so amount of RAM and ROM. So bigger the RAM, you can handle more and more amount of number of variables, and bigger ROM means you can write bigger programs in that chip. Number of IO pins. How many input output pins are available to interact with the external world? More the number of IO pins, more the number of devices you can connect with that particular device, or the microprocessor or microcontroller, not microprocessor, microcontroller. So more number of IO pins. Different peripherals available with the IC, like timer, ADC, DAC, or any other peripheral which is available. Cost per unit. This is important, but it is not that important in a long run, because if you are handling all these things in priority, if you are keeping these things in priority, then in long term this cost per unit becomes lower and lower, because you are saving so many other resources by that time. Okay, power supply options, like whether it can support single power, or it can support dual power or multiple types of power. Like here in this case, we saw that this device can support 2.7 to 5.5 volt. So lower voltages are also applicable. So are these microcontrollers providing you this kind of facilities or not? Like it can support 2.8, 3.3 and 5 volt or not. Okay, so or there are microcontrollers which can only support 5 volt, so it will be better to go for those microcontrollers which can support more number of different types of power supplies. Okay. Okay, so at last, one of the most important thing is the availability of software development tools. It is not that you just go and buy that microcontroller, then of course you have to write the software for it, or you have to write codes around it, and then you have to upload that code into that microcontroller to make it work. So definitely you will need some sort of compilers or assemblers, and of course if possible debuggers, inbuilt debuggers if possible. Okay, so these kind of softwares are also important to be checked before buying the microcontroller. Otherwise you will buy a very complex microcontroller, but you will end up with a compiler or a software which is not that easy to handle. Okay, so better always prefer those microcontrollers which have their own compilers or assemblers which are very popular in the market. Okay, so we have to keep all these things in mind before entering into the microcontrollers world or embedded world. Now let us introduce the 8051. Okay, and 8051 was introduced by Intel. Remember, in that era Intel was one of the biggest supplier of be it microprocessor or microcontroller. But later, with respect to time, there were many companies evolved which started developing microcontrollers and microprogram. Now, like I said, at present ARM is one of the biggest microcontroller designing company. Okay, 8051 is 8-bit microcontroller. I believe you know what 8-bit means here. Okay, it is an 8-bit microcontroller. What 8-bit means? What is the advantage of having 8-bit or having 16 or 32-bit microcontroller or microprocessor? What is the significance of the bits in an embedded device? Ayush Mangal.
Yes,
हाँ, तो किसी भी सिस्टम में नंबर ऑफ बिट्स का क्या फायदा है?
so instruction size and number of word size.
Okay, so definitely, so the number of bits in a microcontroller specifies two things. One is the word size. Word size means how many different combinations of these bits can be used to generate a word. So if it is 8-bit microcontroller, then definitely you can have maximum 2 to the power 8 different combinations. So the maximum word size or the range of word size will be 0 to 255. Okay, this is one important factor. So the bigger the bit system, the larger the number you can work on. Okay. Secondly, it also tells you how many different types of instructions are possible. Okay, instructions available. So if you check 2 to the power 8 means you can again have 256 different instructions maximum. Okay, 256 instructions that is possible. Okay, this is maximum. Okay, now these two are very important. So higher the bit size in the microcontroller, higher the word size, or you can have larger number of instructions available for your programs. Now 8051 supports 128 bytes of RAM. Keep this thing in mind. Only 128 bytes. Now if you talk about your computers, you may say, sir, I have 16 GB of RAM. It's a huge memory, 16 GB. Okay, when I bought my first desktop, it had only 20 GB hard disk. Okay, my hard disk was 20 GB. Now 16 GB is the RAM itself. Anyway, so 8051 has got only 128 bytes. So you have to be very precise when you are writing a program how to manage the variables, because those variables will be consuming RAM. Okay, so 128 bytes. That means in simple words, only 128 different numbers. Okay, you have 4 kilobyte of on chip ROM. 4 kilobyte. So that means you can write maximum 4 kilobyte long program that will range from 000 to FFF. Okay, in hexadecimal. So this is the range of memory in which user can write his program. User program can reside in this particular range. Okay, there are two timers. There are two timers available with the 80. Oh, sorry, this is 8051. Okay, this is 8051. So there are two timers available, inbuilt timers for serial communication. There is one serial port by which you can communicate with the external world. So we call it UART. Okay, so there is one serial communication port available with that. There are 4 IO ports available. Now 4 IO ports, each of 8 bit. 4 IO ports means 4 into 8. That means you have 32 pins which can be connected to IO devices, input output devices, be it switch or LEDs or small motors or any other device that you want to connect with. So there are 32 pins available for that input output reading or writing purpose. Okay, then of course it supports 6 different interrupt, or we can say it supports 6 different interrupt sources. So you can connect 6 interrupts to this microcontroller and they can handle 6 different interrupts. Of course, these interrupts will have their own priority also. Which one has to be served first and which one has to be served on later basis. So this is all about the specifications of the 8051. Okay, now I believe most of the things that you see here were there in the 8085 also, because 8085 was also 8-bit microcontroller, though it does not have any RAM, but it has got 64 kilobytes of, it can support 64 kilobyte of ROM, and there was no timer. We will come to that. Serial communication, there was serial communication available with the 8085 also. Okay, using SID and SOD pins, and there was no direct IO ports available, but here you have IO ports. Remember, 4 port means you will have something like this. The port 1, port 2, port 3 and port 4, and each port can support 8 different lines. Okay, 8 lines. Here also this can support 8 different lines. Okay, so in total, if you are using 4 different ports, you can have 32 IO lines. Okay, and in 8085 also we had multiple interrupts, 5 hardware interrupt and 1 software interrupt. Here also we have 6 interrupts, but these interrupts are interrupt pins itself, so you can connect the external hardware to these pins directly. Okay, so there are so many different variants which evolved with respect to time. Okay, once 8051 was designed, many companies started to develop different variants of 8051. Okay, so Atmega, this is Atmel company. Okay, Atmel started developing the 89C51, then like I said 89S51, then C5134, and now after that there are so many other companies also which developed their own microcontrollers based on this particular architecture, 8051 architecture. So that means when a microcontroller is based on a specific architecture, all the codes will be compatible. Codes will be compatible. That means all these instructions which are there for 8051 will work in those different variants also. So 8051's are instruction set can be used for all these other variants also. Of course, these variants may have some additional instructions available with them, but along with that, 8051's all instructions will be supported by these variants. Okay. So this is all about the introduction of 8051. Now let us look at the architecture. Before entering into any hardware, we have to understand what is the architecture of that device, be it microprocessor or microcontroller. Of course, there will be a CPU. Okay. CPU, we can say this is the microprocessor. And these microprocessors are connected with so many different peripherals. And these arrows are which are showing the direction of the bus. For example, this bus, we can say it is bidirectional. This is unidirectional bus, unidirectional bus, unidirectional bus, unidirectional. Okay. So here you can see these are bidirectional bus. So input output ports can take input or can send the output to external world also. But at the same time, internal bus you can see it is bidirectional. So from the port, the microcontroller or microprocessor which is present in the microcontroller can read or write the data to the port. Rest you can see almost all the buses here are bidirectional. Microprocessor can read the timer or even load the timer with some specific instructions. Similarly for the serial communication also. Okay, but the CPU cannot send interrupt to the outward world. Remember here. Okay, so this is just unidirectional communication. Of course, CPU is not going to talk to the oscillator also. Okay, so there is no reverse arrow in this oscillator also. The oscillator's clock, because this is oscillator, okay, and here you will get the clock frequency. So the clock microcontroller or microprocessor CPU don't have to talk to the oscillator. The oscillator will send the clock. So that is why it is unidirectional. So rest of all the pins are bidirectional, okay, except oscillator and interrupt controllers. Now if you check here, the first variant was 8051, but later it was developed to be 8052. So you can see how the technology evolved and how things got more and more complex and more features were added into the new generation of microcontrollers. Now if you talk about the present microcontrollers, you will find a lot of difference between these things. Of course, starting from the very bit itself. This is 8-bit microcontroller. Now you can see 32-bit microcontrollers, even 64-bit microcontrollers. And of course, with many different types of peripherals available with them. Okay, so this is all about the architecture. Now let us talk about common registers available with the 8051. 8051 has got its own accumulator, just like 8085. All the results of any ALU operation will be stored in the accumulator. Okay, and of course it has got temporary register bank or registers like B. So accumulator is there, B register is there, and then you have R0 to R7. This is dependent on the bank. Okay, I will come to that why it is not always the same. Okay, so but in any case you will have R0 to R7 to store eight different values. Okay, so you can store 8 different values in R0 to R7, and of course A and B. Remember, all the results of any ALU operation will be stored in the accumulator itself, just like the 8085. Other than that, here there is a data pointer which points towards the data only, and then there is program counter which points towards the location where the program is residing, just like the program counter in your 8085. And then stack pointer is also there. So this program counter here there should be bracket. So this program counter is 16-bit register. This is also 16-bit register. Okay, and this dptr can be divided into two halves, dph and dpl, higher significant bits and lower significant bits of data pointer. So it is 16-bit. Rest of all these registers are all these registers are 8-bit registers. These are all 8-bit registers. Okay, 8-bit register. Now, okay, I'll come to this later. Okay, now let me go to the, okay, shall I go in this? Any doubt till this part? Any doubt till this part? 8051s. Okay, so let us briefly start with the programming of 8051. Okay, here I am not going to talk about all the different things that are available in 8051. Definitely it will take quite some time to master this microcontroller. Okay, so but before that we can start understanding how to write simple programs, so that in future when you start the lab, you should be able to write simple programs based on the instruction set available. Okay, so let me show you the instruction set if possible, not this one. Let me check. Okay, we will come to that, but let me first talk about my notes. Okay, here instruction set. Of course, when we talk about the instructions, the first thing that should come to our mind is how many different types of addressing modes are there. Like in 8085, we had 5 different addressing modes, like direct, register, indirect, implicit, and all. Here also we have different modes in which the 8051 instruction set is divided. So the first instruction set is called a family of instruction set, or mode of instruction set is your immediate addressing mode. Immediate, if you recall from the immediate addressing mode in 8085, all the instructions where you have I, like MVI, LXI, so these I are representing that they are using immediate addressing mode. But if you carefully check this thing, after these opcodes there were always data provided to you, if you recall this. So always in all these instructions, the second operand was your data itself. Similarly here also, immediate addressing mode, though here there is no I in these instructions, but this can be classified that all those instructions which provide directly the data itself are your immediate addressing mode. Here, for example, a hash 10. So the data 10h will go to accumulator. Move R0 hash 0AH. Okay. So 0A, data 0A will go to R0. If you recall, there was a register bank A, then B, then you have a range of R0 to R7. So when we are writing, when we will execute a code like move a comma hash 10h, then in that case accumulator will get data 10h, which is 16 in decimal. When we say move r0 comma hash 0a, then in that case register r0 will get 0a h data in the register. Okay, so here immediate addressing mode cannot be classified by I. Remember, in 8085 you can classify them or you can distinguish them by looking at I in the instruction. Here there will be no I, but we can distinguish by looking at the data, that the data is provided after the opcode itself. So this is immediate addressing mode. Then comes the second family, which is register addressing mode, just like the register addressing mode in 8085. Here we will provide the register, okay, to provide the data itself. Okay, we will not provide the data directly, rather the data will be residing in some register, and that register's data will be actually moved or shuffled. Okay, remember, this is one important thing to keep in mind. Data may not be copied from one register to another register. So what does that mean? That means you cannot write a code like move r1 comma r3. Okay, remember, this is your source and this is your destination. This is the same protocol which is followed in 8051's programming also. So the data present in R3 cannot directly be moved to R1. Remember, data may not be copied from one register to another register. This is important. You can only move data from one register to accumulator only. Then direct addressing mode, where you have the data, okay, provided, but here remember, this data here, the opcode, do not have hash in them. If you check here, okay, if you check here, there is no hash in this instruction move a comma 20h directly. So that means the data present in 20h, that is, here the data is showing memory address. Okay, 20h is memory. When you put hash before the hexadecimal value, then it becomes a data. When there is no hash, then you are transferring data from a memory to accumulator. Okay, remember that. And you can move data from one memory location to another memory location also. Or these are all RAM locations. If I show you something like this, okay, so I didn't finish this slide anyway. So here the RAM is divided from 00 to 7F. Okay, so you can see that I cannot write here. The smallest address is 00 and the largest address is 7F. So now if suppose someone asks you what is the range of RAM, how many different addresses can be located in the RAM, then what is the range of RAM here? 256. Clear? So there are only 256 memory locations in the RAM. Okay, in the RAM, and they are actually segregated or actually differentiated in different levels. Like 0 to 7H is register bank 0. We will come to this also. 8 to F, register bank 1. 10 to 17, register bank 2, and 18 to 1F, register bank 3.
Sir,
Ah,
सर आपने कहा था ना कि इसमें 128 बाइट्स ही आ सकती है, तो सर अगर 256 हो गए तो 256
नहीं
बाइट्स
नहीं
नहीं हो
नहीं,
जाएंगे?
वेट 256 7F कितना आता है? 128 है ना? कितना है 7F? वेट अ सेकंड। 7F, लेट मी चेक। साइंटिफिक प्रोग्राम, one 128, sorry, this is not 256 here. 128, this is 128, 2 to the power 8. Okay, so this is 128, 128 bytes. Okay, clear. Now if you see here 0 to 7, so this is 8 different locations. Okay, similarly here also you have 8 different locations. Here also you have 8 different locations. Here also you have 8 different locations. So you have 4 banks 0 to 3. So there are 4 banks. Okay, let me first erase this part. Okay, so there are 4 different banks, bank 0 to bank 4, and all individual bank can have 8 different locations, 00 to 7, starting from 00 to 7, and 18 to 1F. Now it is important to keep in mind, by default, register bank 1 is your stack by default. Okay, this is your stack address. This is by default. By default means now we can deliberately change that stack location also. So yes, user change the stack location. Yes, user can change stack address. We will learn how to do that. Okay, and rest, by default, when you are saying R0 to R7, okay, in the previous we saw that there is register A, B, and then R0 to R7. By default, these R0 to R7 is register bank 0. Okay, this is the by default address. So by default, register bank 0 is your R0 to R7. Can the user change the register bank 0? Yes, user can change register bank. Okay, okay, register bank. So which register bank you want to use at any time, you can change that also. So it is not necessary that you will always point from R0 to R7, which is located at 0 to 07. No, you can change that also to third bank also. That means in some part of your program, you can access this 7 or 8 addresses, but for other half of your program, you can actually point to this particular address also, register bank 3. Then there is separate RAM location, which is 20 to 2F, which is for bit addressable. That means user can access single bit also. So that means you can just go and directly write one bit or change one bit in that location between 20 to 2F. Whereas in these cases, you have to load at least 8 bit in one chunk. You cannot go and directly change one bit only. They will not support, this bank will not support changing only one bit. Whereas this particular section 20 to 2F, you can change a single bit also using the instructions available. We will come to that and see that how to do that. And then of course you can have your scratchpad RAM, or you can simply call it simple user RAM, where you can play around. Okay, user RAM location where you don't have to worry about that part. Okay, we will see how to switch from one particular segment of RAM to another segment of RAM, and when to switch from one segment of RAM to another segment of RAM. It is not that you can just jump from one segment to another segment for fun. There are specific requirements, necessity, when you will go from register bank to register 3, or when you need to change the stack from this location to somewhere in this in this location or in this location. It depends, not in this location, bit addressable, no. Okay, you can go to the user pad or use scratch pad RAM location also. So you can shift the stack from this particular default address to another address also. Anyway, so okay, so when I was talking about this particular instruction 20h, so data 20h is not going to move into accumulator. Here 20h is not a data. This is 20h is a RAM memory location. Okay, 20h will be somewhere in the memory location of the RAM. We will come to that. Okay, so the RAM's data will come to the accumulator. We can move the data from 40h memory location to another memory location. This is allowed. Moving data from one memory to another memory is allowed, but moving data from one register to another register is not allowed. Like R0 to R7. Okay, here when Rn is there, we are talking about R0 to R7. Okay. Okay, so then definitely
सर R0 R7 भी तो किसी ना किसी मेमोरी पे होंगे, तो सर अगर मेमोरी से अगर डेटा ट्रांसफर हो रहा है तो सर R0 से R7 में नहीं हो सकता.
R0 से R7 में नहीं हो सकता क्योंकि उस टाइम वो पर्टिकुलर रजिस्टर बैंक सेलेक्टेड होगा. मेमोरी मींस तुम किसी और मेमोरी लोकेशन 30h 40h कहीं और मेमोरी लोकेशन R0 R1 नहीं है. यू आर नॉट, ये R0 लिख रहे हो क्या? दिस इज नॉट R0. इज इट R0? नो. Are you calling it R7 or something? No. When these are not represented by R, then it is memory directly. Okay. When you use R0 to R7, you are pointing to the bank R0 to R7. It is bank 0, 1, 2, 3. In that the instruction itself you have to specify R. Here are you specifying R in this? No. Here you are specifying to a memory location itself. You don't have to worry about that. अगर R लिखा होता है R0 to R7, then you cannot move it. But if you are using direct memory address, then you can use it. Okay. Similarly, you can move the data from accumulator to port P1, P2, P3, P4 because there are 4 ports available in the 8051. Okay. So you can load the data present in accumulator to port to make something on or off. This is direct addressing mode. Then comes indirect addressing mode. Indirect addressing, if you remember, in 8085 we used M, like move A, M. So the M was basically a pointer, right? So here also indirect addressing modes basically are some kind of pointers which are not the direct location, but indirectly you can point to that location. For example, in this case a register used to store the address of the destination or source data. Register is used to store the address or data. Move 20h, this is data because you are using hash. So the data will go to the R0. This is indirect addressing mode. At the same time, @R0. @R0 means now 55h will go to the location pointed by the data present in R0. So whatever the data is present in R0 will actually point to a memory location, and in that memory location this data will be loaded. For example, in R0, suppose you have loaded 20h prior to executing this instruction. So R0 contains 20h. This 20h is can either be used as a data for addition or subtraction. At the same time, it can be used in indirect addressing mode as a pointer. So this 20H is pointing to a memory location, and in that memory location, okay, in that memory location, you can load the 55H. What does that mean? So remember, R0 is the register bank 0 or register bank 0, 1, 2, 3. In that, suppose you have loaded 20H. So this 20H is pointing to a memory location. Okay, 20H is a memory location. In that, you will load the data 55H. Okay, I will show you that when we will start simulation. Okay, okay, move A at the rate R0. So this copies the content of address which is stored in R0, not 20H, because here we are talking about the example 20H which is present in R0. So rather than directly downloading the data from that register, you are going to a memory which is pointed by that register and then loading that data into accumulator. Okay, for example, suppose R0 contains 40H. Okay, and definitely there is a 40H in the memory also. In the memory location 40H, suppose you have 05H, which is the data. Okay, when you execute this instruction, accumulator will not get 40H. Remember, in this case, the accumulator is not going to get 40H because you are not just directly loading the data into accumulator. So this is not going to do that. Whereas accumulator will get 05H. This is right. Okay, because at the rate R0 is pointing to 40H, assume the memory location. In that memory location, you have the data. That data will come and get loaded into accumulator. Okay, so this is actually a pointer. When you use star or asterisk in your C program, this is the same thing that you are doing in your C program also. Okay, asterisk, when you use asterisk pointers. Okay, and there are other instructions. Okay, let me just erase all these things. There are some exceptions that you have to keep in mind when you are using these instructions, like which are shown in red. But when you are practicing the code, you will by heart these things. It will be automatically always recalled. Okay, like in this case, only register R0 and R1 may be used for moving the data to or from internal memory when using indirect addressing mode. You will not use R3, R4, R7, only R0 or R1. Okay. Similarly, instruction set can be divided into 4 groups also. Like similar in case of 8085, you have direct addressing modes. Then the same instruction set can be divided into the categories, like whether they are used for data transfer, they are used for arithmetic operations or logical operations or branch instructions. Almost same instructions are there. Okay, I think in 8085 I have not talked about push and pop. Okay, so data transfer, moving the data from one location to another location or one memory to another or memory to temporary register. Similarly, here in arithmetic instruction, if you see add, there was add in 8085, subtract was also there, increment, decrement. These are all present in 8085 also. But here in 8051, you can directly do multiplication and division also. These instructions are available with 8051. Okay, which was not available in 8085. Now here the branch instruction, you can recall, call was there, return was there, jump was there, jump if 0, jump not is 0, no operation. These are all there in 8085 also. There is nothing very different from 8085. But here a small change is there. L, then there will be S. Okay. So there will be this kind of small trivial changes, small changes in the opcodes. L means long jump, S means short jump. We will come to that. We cannot cover the 8085 in 1.5 hours. Anyway, okay. So okay, let me show you the. Now I have almost 10 minutes. I will show you the software in which you can execute your program. And what is that software, how to use that software and all. Okay, so before that, pen कैसे हटेगा? Okay. So in this course we'll be using this particular software. You can download it from internet. It is of some few MBs, only 1 or 2 MBs, I don't remember. You can just go to Google, and in that you can type edsim51. Okay, edsim51. This is the website, edsim51. Okay. This is a free software. That's why I switched to this particular software. And because we have to use interfacing devices in the second half of our lab, we have to switch to this particular software. Anyway, you can download the software from this particular link. Don't download this edsim51sh. We will be using edsim51 dynamic interface. Download this part, this software. It is of some maybe KBs, I think. I don't think it is some KB. Okay, 400, 500 KB maybe. Anyway, so download this software, and you don't need to install anything. First thing, okay. Then along with that, you can play around the examples which are provided in the software. We will come to the software's example files and all. Anyway, so when you download that software, and extract that, you will get edsim51di dynamic interface. In that you will get this particular jar file. This is Java file. Okay, just double click it and you will reach to that software, edsim51. Okay, so now let us talk about the software first, how the interface is, what are the important things to keep in mind in the interface. Wait a second. Download. Okay. Now in this part, left hand side topmost region, there is one section which shows you what are the things available with this particular software. So you can specify the system clock speed 12 megahertz. You can specify different clock. On that basis, the speed of the programming will change. Okay, so these are all timer related, TH0, TL. So these are timer related windows, tmod, tcon, mode of operation of timer and all, control of the timer and all. So this is all timer related part. We don't have to work on that part right now. Okay, here you have the register bank R0 to R7. We will learn how to change the bank in the next class, but anyway, this is the first register bank. By default it will be register bank 0. Then you have B register, accumulator, PSW. PSW here is your flag. Okay, just like your flag, here also you have PSW. Even in 8085, flag is also called PSW, program status word. Okay, it tells you the status of the program. So PSW is there. Again, we have to look into that in detail. What are the different bits available in PSW, and by those bits what we can predict. For example, in the 8085 we had carry, auxiliary carry, parity, sign, and zero flag. Here, what are the flags available with this PSW? We will look into that in the next class anyway. Then interrupt enable, interrupt stack pointer, IP. I don't recall IP. I have to recall that anyway. PCON. Okay. These two are your DPTR, data pointer register. So DPH higher and lower address. Okay. This is interrupt enable. IP, I don't recall IP. I don't recall. Anyway, then this is the PSW. That means the flag, status of the flag. You can see from all these different 8 bits which of these flags are active or deactivated. Okay. Then you have the RAM location 00. This is the 00 where you have right now have 31. 00 to 7F. This is the end of the RAM. So you have 00 to 7F, that is 128 different byte locations where you can store your data for random access memory or variables you can store here. Okay. Then coming to the second window, this is the window where you can write your code. Okay. This is the window where you can write the code, and this is reset. Reset, you see, to reset the program, that means the program counter becomes 00. Then you have assembly. Okay, that means assemble the code. We also had the same in 8085 Then you have run. That means if you press this one, the whole program will be executed in one single click. You can load a new program. You can create a new program, load a program from the hard disk, okay, save the present program, copy and paste the program. That is all different. This window, okay, here where it is written reset PC equal to 0, this is the place where you will get the messages. For example, I press assembly. So here you get the message, no errors detected. Whereas if I write something wrong here, okay, reset, if I write something wrong here, like 0F, okay, now there is no such instruction. If I do that, you see unknown label 0A. So you get error in the first line itself. So you remove that, try to assemble, you get the message in this. So this is your messenger, a kind of messenger. Okay, done. And now you can see the program is loaded from 0000 to 000A. But remember, this particular 8085 has got 0000 to 0FFF is the range of memory in which you can write your program. I told you that 8051 supports only up to 7F. Okay, so you have to remember that. So where is that? We did that, I think. Okay, 7F maximum 4K. Okay, so it can support only 4K memory locations. So this is the program location. This is the instruction, the opcode, and then the operand. Okay, you can separate the window just like the window for listing and all. You can get the listing from here itself. Anyway, now in the bottom, these are all the peripherals that you can connect. Which are the peripherals available? You can have strip of LED starting from 0 to 7. So there are 8 LEDs. And then you have keypad. Okay. Then you have the scope, which will DAC for the digital to analog converter, how much voltage is coming. You have 7 segments. Okay, this is bar LEDs and all. Now you can have window for serial communication where you can set the baud rate, the communication speed rate and all. We will come to that later. Okay, and then ADC where you can provide the analog data and you can convert it into a digital using a program. And this is a stepper motor, okay, which can rotate depending on the instructions that you pass to the program. But remember, these all peripherals are connected to specific addresses of the 8051. So we must know the schematic before writing a program. It is not that we just write a code and the stepper motor will start running. No. So for that, you can look here in the last window. Like port 0.6 is connected to keypad column 2. 0.5 is connected to column 1. So port 0, you can see almost most of the pins are connected to the keypad itself. Port 1, in case of port 1, you can see they are connected to LED segments. Okay, 7 segments LEDs. Okay, at the same time they are connected to DAC. Also at the same time they are connected to LCD also. LCD, here you have the LCD. Okay, this is LCD. So you can send the data to any of these 3. Like at the same time they will glow the LED, they will glow the LCD also. At the same time you can do the digital to analog conversion also. ADC is connected to port 2 where it's connected to switch and all. Now anyway, we will look into that later. So first of all, let us start and execute a simple program. Reset. You wrote the program and assemble. Okay, and I don't know how to clear this particular window. Reset. Let me check. Okay, so it is 00 now. Let me try and copy the paste. Okay. Okay, so here we have the program. Let me check if there is any error. No error is there. Okay, reset. So now let us try to understand what is happening here. Move a comma #0. #0 means 0 will be moved to accumulator. But if I want, I can write it 05H. Okay, so 05H will go to the accumulator here. Then R5, add a comma R5. So before that I have to move some data into R5 also. Move R5 comma #02H. Okay, so R5 here in this window. Okay, R5 is here, accumulator is here. So in R5 I am going to enter 02, in accumulator I am going to enter 5, and then I am going to add R5 with accumulator, and the result will be stored in the accumulator itself. So 07 should be stored in accumulator, and then R7 is also there. So I will move some data into, okay, I will just comment it here. Okay, I will just comment it here. I don't want this instruction to be executed. Then add a comma 12H. You can directly add some data with the accumulator also. And S jump here. You see, S jump means short jump here. So this is the label here because there is a column with that. And here is also there. So that means this line is going to repeat for infinite time. So the pointer, when the program counter reaches here, the program counter will stick here and it will not change after that. So assemble the code. And then let us start step by step. Okay, rather than running it in one particular click, you can go step by step. So you see here in accumulator, no, in R5, we have moved, because R5 02, we have moved 02 into R5. A in accumulator, we should get 05. Yes, in accumulator, we have 05. Now we are going to add the content of R5 with accumulator, and the result will be stored in accumulator. 07 in the accumulator. PSW, program status word, has changed. See here, program status word has changed. This is flag. Okay, we will see what is the significance of this. Now, again, next step. So add a comma hash 12. So 12 data 12 has been added with the accumulators content. Before it was 17, now it become 7. Before it was 7, now it is 19, because 7 plus 12, 19. And then you have reached to this location. You see the program counter has reached to here. The program counter has reached to 0007. And yes, we are at 0007. So program counter we can see from here also. And then if you keep it running, you see there is no change in the program because you are stuck in an infinite loop. Okay, and you will never go to this particular instruction end. Okay, so in this way you can execute simple programs and check whether your program is running or not. So for that we will have to go through the instruction set. In the next class we will talk about the complete instruction set, and we will see how to write simple programs and then interface the ports so that you can make the LED glow, run the motors, make the LCD and all those stuff. Okay, by that time you can just go through this presentation. In the next class we will go through more complex programs and learn how to go for 8051 in more depth. Okay.